Okay, so this one of the more important section under cone is something called frustum, because frustum is a weird shape. It is a weird shape created by removing a small cone. So we remove a small cone from a big cone. So you can see, right? That means originally it's supposed to be a big cone. And then the small cone is going to be chopped up. So this part is taken away. So essentially you're left with something that looks like this. Sometimes it can be a decorative ornament, or it can be a flower pot. Okay, so anyway, because of this, right, it makes the calculation of volume and surface area a little bit difficult. The difficult part lies with the surface area. I wouldn't say the volume is difficult, because the volume is just the big cone minus away the small cone. Okay, so we are supposed to find the volume of the frustum. So essentially, like what I mentioned, I need the big cone. The big cone will be the one OPQ. Okay, this black one. And then I'm going to subtract the small one. So it's quite easy if you got the dimension. So I'm going to subtract like this. But if you realize, I do not have the full height of the cone. I also do not have the height of the small cone. So in fact, right, there is a similar triangle. So this is where they have a similar triangle. This become a similar triangle. It become a similar triangle with the big triangle here. So at this stage, you should have already learned similar triangle. Okay, you should already learn the similar triangle part. So this similar triangle, if you still remember, what about the height ratio? Okay, so if you look at the small parts, the height is h. And if you look at the full height, the height is x plus 20. So that's the height ratio. And then I've got the radius ratio. So the radius ratio is the small radius over the big radius, and it can be reduced. And if you still remember, because of similar triangle, the ratios are the same. So which means, right, this ratio will be the same. So you actually need to use similar triangle so that you can find the height of the respective cone. So this h is the height of the small cone. So this is the height of the small cone. And then the height of the bigger cone will be this plus 20. So from here, you can find the volume of the big cone. The radius is the one that's bigger. So again, keep it in terms of pi. Okay, volume of the small cone. Do it part by part. There's no need to do everything at one shot and get yourself very, very confused. Or sometimes you might even make careless mistake. So do it slowly. Okay, focus on each part. Then I will just calculate the volume of the frustum, which is the big volume subtracting the small volume. And then I will punch up. So it's a chain of decimal. Okay, but if you're going to round off to 3 SF, it looks very different. This is 3 SF. Okay, so I'm going to tell you, right, if let's say this is finding the volume of a frustum, if I need to find out the surface area of the frustum, I actually need a big pi RL. That means I got to do the curved surface area. Based on this one, I got to do a pi RL. Then based on the small cone, I got to find the small pi RL. And then I need to subtract away. So if I subtract away, then I will get this part, the curved part of the frustum. And then you will need the big circle and the small circle. To make up the full total surface area. So surface area for a frustum is not so easy because of the curvy part. The yellow part is actually a subtraction from the big cone curved surface area and a small cone surface area. So in this question, we are not asked to find, but I'm just going through first. It's quite possible that you are asked to find. So a frustum is a question where it involved the use of similar triangle. And if I'm going to continue to ask you about the surface area of a frustum, it will include Pythagoras theorem. So during exam, it becomes a very, very long question. So this is the idea of a frustum.